Okay, hi folks, this is Chemistry Revision and we're looking at chapter C8 on rates of reaction. Remember, rate means how fast something is happening, and you can measure rate by either looking at how quickly products form, or in this case, how fast reactants are used up. The mass is going to go down in this flask because as the marble chips and hydrochloric acid react, they'll make carbon dioxide gas and it will escape. The less time it takes for the mass to reduce, the faster the reaction is going, and so you say it has a bigger rate. You can see that over time the mass of the reacting mixture goes down, but the loss of mass is fastest at the start, and that's because at the start of the reaction the chance for collision is greater. We could use this as one of the methods to investigate factors that affect rate of reaction, and if you look at this graph you'll see three lines where the same experiment has been done with three separate strengths of acid, and you can see that the steeper line is for the higher acid concentration. In other words, if you make the acid more concentrated, the rate of reaction increases. Here's a method we can use to collect the products of a reaction. This could be the same reaction as before, but we're collecting the gas, and you can see the curve again is steeper at the start and levels out. The volume of gas being produced is being measured, let's say every minute. The reaction is faster at the start and the reaction keeps on going, but the rate is slowing down. When the line gets horizontal, that would mean that the reaction has stopped and the one or more of the reactants has been used up. We could say the limiting reactant has been used up when this reaction finishes. Our final method in the required practical should be an experiment you've definitely done before, and in this experiment you reacted sodium thiosulfate and hydrochloric acid. The solution goes cloudy, sort of creamy yellow colour over time, and this is because one of the products in this reaction is sulfur, which is insoluble and makes the solution become opaque. If you measured the amount of light passing through the flask, you would get a graph shown like this. So at the start, when the solutions are at their most transparent, the most light gets through, and as the reaction progresses, the solution gets cloudier and cloudier, and the amount of light transmitted through the solution gets less and less. You would have changed a factor and measured how long it took until you could no longer see the cross. So again, we could change the concentration of sodium thiosulfate, we could change the temperature, and we could see the effect of changing that factor on how fast the X is no longer visible for.